Hello and welcome back to this common Lisp tutorial series. As I'm sure you can see by my system clock, it is actually quite early in a Saturday morning, and my first attempt to upload this video has not entirely been successful, so I'm going to have to try again. So, in the interests of expediency, we are going to talk about the reduce function, and it is considered to be one of the trinity of higher order functions. You have map, reduce, and filter. We had a look at map 2 weeks ago. Last week we had a look at the filter functions that are available in Common Lisp, which are the remove and the delete style functions. Let's have a look at reducing. And if you have a maths background, you might know this as fold. Certainly I've seen languages such as Scal refer to this as folding, but all we are doing is we are taking a list of items and we are turning that into a single value, which is not nearly as complicated as it may first appear. I know junior engineers I've worked with have found this to be the most mystifying of them all. So with any luck, what we're going to do here is we are going to demystify this a little bit. So the first thing that we can do is perhaps have a look at the most trivial example possible, which is to just take a list and add all the elements together using the plus operator. And this is what it might look if we were using Common Lisp itself, just using the sum function. Common Lisp, the mathematical operators, the functions here, they're varadic or n-arity, which means they can take more than, they can take many arguments. It's not specified how many they take. So here we can take the plus of 1, 2, 3, 4, and 5, which is 15, which we see there on the right here. Now, if we're going to do this using reduce, and you wouldn't do for an example this trivial, but if we wanted to, here we have the reduce function, and we pass in the function that we're going to reduce everything by, which in this case is the plus function, and then we pass in our list of 1, 2, 3, 4, and 5. And that gives us the 15 that we were looking at. So let's see. Let's try this with, sorry, I think I hit the desk with something. Let's try this with a minus operator. Again, in Common Lisp, we could just use the minus function. And we get minus 13. And the reduce equivalent are exactly the same. So we get minus 13 with that. Now it's worth pointing out that reduce, the order of operators and subtract matters. So this is not the same as this. Except it is, that's interesting. go. So when we have a look at subtract, we got the order of subtract matters, so we're going to start from the inside with 1 minus 2, and so we get to minus 13. So these three lines are equivalent. What we have here is we're starting with the inside out, so we go 4 minus 5, which is minus 1. It gets 1, and we get to 3. I'm not entirely sure how the math works out. The mental arithmetic is not my strong point. It is also 1 in the morning on a Saturday, and I have been out with a friend tonight, so my logical thinking is a little bit impaired. However, I can still demonstrate this. So we have this different order of subtraction operators, and if we wanted to express this in terms of reduce, we could do this using one of the key parameters that can pass in. So this FromEnd, we've seen this before in the other higher order functions. FromEnd changes the order in which things are run. That's fine, and that's where we would change the way the operators are calculated. We reverse the way the values are applied. So that's what FromEnd does, and that's why we get 3. Now there's a few other things that we might want to look at. So here, let me get that correct. So here we're going to skip over the first one and add 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we get 54. Here we would get 45. And here we would get 44. Again, just due to the way that it works out. So here we're starting from 2 and ignoring the 1. Here with the end, we're stopping at 9 and we're not using the 10. Here with start and end combined, we're starting at 2 and ending here at 9 to get 44. So that's just what the start and end key arguments are doing. And we have this from end here. Now there's two other things that we want to look at. So let's say that we are using the plus operator on an empty list, which of course evaluates to 0. So an empty list is falsy, and 0 is the falsy numeric value associated with that. So if we try and reduce that, we get 0. Now we might want to ensure that we get some numerical value. Maybe it's the result of a calculation, maybe it's just to give us some truthy value back. I don't know, it depends on the implementation, but if we're going to do that, so here we're saying initial value of 1, so irrespective of what the reduction did, we always start with a value of 1, so that always goes in. So plus 1 of 0, we still get 1. Here if we start with 2, we'll get 3 because we are adding the initial value 1 to 2. Now there's some nuance to this, so let's have a look. What we saw here where the reduction, the addition reduction of 1, 2, 3 and 5 give 15 with its initial value of 5, we would actually get 20. So we are reducing this all down and we've got this initial value of 5 which is treated as the beginning of the list. We're going to park that for a second. So what we have here, apparently I defined that previously, no matter. We are going to use the reduction with the plus of 1, 2, 3, 4 and 5, and we are going to use a key argument, which is a function of one parameter, which we've defined as square on lines 5 and 6. So if we evaluate that, we are going to get 55. And that wasn't mental arithmetic, this was an example I've already prepared, so although I struggled with the subtraction thing, please be aware that I would not have been able to compute this in my head at the best of times, just in case you were under any illusions. So what we're doing here is we are taking our list and we're going to add the items together, but we're going to first pass each number through this key function, which happens to be squaring them. And that's why we end up with 55 and not 15. Now that nuanced behavior I just mentioned. When we have an initial value and a key function here, it's worth noting that the initial value is not piped through the key function. So here we generate 55, but we have an initial value of 5, and that gives us 60. So this proves that we have an extra 5 coming from somewhere, and that is our initial value. So it's initial value plus the square of 1, which are summed together, and then that is summed to the square of 2, which is then summed to the square of 3, which is summed to the square of 4, which is summed to the square of 5. So when you're using an initial value and a key, please bear in mind that the initial value does not pass through the key function. Just a gotcha. Now let's have a little bit more of an interesting example. We're just dealing purely with numbers here, but there's nothing about the reduction function that inherently means it has to work on them. Numbers. Oh, excuse me. I am going to bed once I finish this video. Yeah, that works. So we define this join stir function, which takes an a and a b. So these functions the functions that get passed into reduce, they must take at least 2 parameters, so that as they get accumulated together, so 1 and 2 go in, and then that gives a value, and that value is passed with 3, which condenses it down, and that value, that computed value of 1, 2, and 3 gets passed in with 4, and that becomes one value. So these are being passed in succession, with each value getting added to and just the next number passed in. So here we have a list of strings, and if we evaluate this, we actually get this comma is comma as comma string, which is exactly what it's doing. So this and is get passed in, so this goes here with a comma and is, and that's returned. So this gets replaced with this comma is for the first value, and that goes into A, and A comes in. So we get this comma is comma, this comma is as A, and then we go comma and then B, so we get this comma is comma A returned, and that's all that replaced. And then that goes in as A, and we get this comma is comma A, and we do comma and then string as the B value to build that up, and that's what's going on here. So that's an example of how we might use strings here with a join method in a reduction function. There is a lot more that we could go into. There are many examples. We could plug class into this ultimately, I'm sure, and one of the things that I want to talk about next week is how we combine the reduce function with the map functions that we had a look at, specifically map car. Although given us enough examples, we could use any kind of map function to plug into reduce, because map will transform our values, then we'll use reduce to combine them all together. And in fact, line 31 is a little bit like that, because we're using the square key function to transform elements, but we're not getting a list of transformed elements. We're transforming them on the fly as we get them. So it is a little bit different to line 31, but line 31 is doing something similar that we can see. So I hope that was informative. Thank you very much for watching. I do appreciate your continued support, and I can only apologize about the issues with the video earlier today with regards to the uploading issues. I'm going to upload this now. It shouldn't take too long, and I will see you in the next video, hopefully sometime next week, and we won't have these issues. Take care, everyone.